Hello, welcome to lecture 12. Today I am going to talk about arithmetic progressions. This is based on chapter 5 of Mathematics for class 10 based on NCERT syllabus. My name is Sangam Banerjee and my details are given below. So what is arithmetic progressions? This is a general form. You have this first element. The second one has some finite difference, a plus d. The third element will be a plus 2d and so on. First element I label as a1, that is a. Then the second element is a2. a2 is nothing but a plus d. The difference between the second element and first element is d. And the third element is a plus 2d. Again, the difference between the third element and the second element is a plus 2d minus a plus d, that is again d, and so on. The difference between the consecutive elements will be difference of d. So I can write nth term as an is equal to a, the first element, a plus n minus 1 times d. So this is the second element a2, that is 2 minus 1 is 1, so difference is only 1d. Then a3, it is 3 minus 1 is 2, the difference between the first element and this third element is 2d. And similarly, the difference between the fourth element and the first element is 3d. So here that's why I write a4 is 4 minus 1. So for an will be n minus 1d. So the whole this lecture will be based on this. This is a very important formula. So please remember this for the arithmetic progression. So I can say that arithmetic progression is a list of numbers in which each term, these are the term, first term, second term, third term. Each term is obtained by adding a fixed number of preceding term except the first term. So here each term is obtained by adding a fixed number. Okay, this number d can be some number to the preceding term. So if you add this d again, you have 2d. Then again you add d here, you will have 3d. So this is what is the arithmetic progression. This fixed number is called the common difference. This d is called the common difference of the arithmetic progression. Remember that it can be, this d can be positive, negative or 0. So here positive means the number will move in a positive direction on the number line, and negative means the number will move in the negative direction on the number line, and 0 means it will be same repeating a comma a comma a comma a. So there is no diff. So this is a 0. So that also can be considered as arithmetic progression with difference of 0. So finite number of terms in an arithmetic progression is called a finite arithmetic progression. I may sometimes call it AP. This is the abbreviation of arithmetic progression. And not finite are called infinite AP. To find AP, you will need to know both the first term A and the common difference D. So you have to know the first term A and the common difference D. And these are the nth element, okay, or nth term. So here, for example, if the first term A is minus 7 and D is minus 2, then minus 7 minus 2 is minus 9, then minus 9 minus 2 is minus 11. So this is arithmetic progression starting with minus 7 and with a difference of minus 2 added to each term. If A is 1 and D is 0.1, then AP is 1.0, this is the first term, then 1.1, 1.2, this difference will keep on adding. The difference between this element and the preceding element will be difference of 0.1. So this element and this element, or this term minus this term, is 0.1. So now for A equal to 0 and difference is 1.5, that is 1.5, the AP will be 0, comma 1.5 because difference is half. So A is 0 plus 1.5. Then again you add 1.5 to this one, you get 3. 3 plus again 1.5, you get 4.5. And 4.5 plus again 1.5 is 6, and so on. So this is again arithmetic progression. And if suppose A is 2 and D is 0, you have 2, 2, 2. As I mentioned here, if this is 0, then this A1 will be A, A2 will be A, A3 will be A. So in general for an AP, this is your terms A1, A2 up to AN. We have the differences between this term minus the preceding, that is A of k plus 1 minus AK. K can be from 1 to n. Here if k is 1, then A2 minus A1. If k is 2, then A3 minus A2. So now let us discuss exercise 5.1. In which of the following situation does the list of number involved make an arithmetic progression and why? So number 1, a taxi fare after each kilometer when the fare is rupees 15 for the first kilometer and rupees 8 for each additional kilometer. So is it arithmetic progression? Yes. First one is 15, then you add 8, 23 plus 8, 31. So this is like an arithmetic progression from our definition. That is an is equal to a plus n minus 1 times d. That is the main formula which you have to remember in this whole chapter. The whole thing is revolving around this formula. The amount of air present in cylinder when the vacuum pump removes 1/4 of the air remaining in the cylinder at a time. So first is volume is V, then you remove 1/4, that means 3/4 is remaining. So again 3/4 of this 3/4 V is remaining. So this is 3 by 4 the whole square into V. So you see it is not arithmetic arithmetic progression. Okay, this minus this is not equal to this minus this. The difference is not same. Just subtract and see it. It is not same. So no. So this is not arithmetic progression. And here the cost of digging a well, every meter of digging, when it cost rupees 150 for the first meter and rises by 50 for each subsequent. So this is arithmetic progression, because rupees 150 will cost for the first meter and then 50 for consecutive subsequent meters, that is 200, 250. So this forms an arithmetic progression and the difference between them is 50. The amount of money in an account every year when rupees 10,000 is deposited at compound interest at 8% per annum. Again, this is a compound interest, not a simple interest. Simple interest would have been arithmetic progression. So the starting amount is here 10,000, and if you add 8%, that is 1 plus 8 by 100, that is 1.08 times, that is 8%. If you add to this 10,000, this is the first year you get it. Second year again 8% of this amount, so this again you have to multiply by 1.08, so this becomes a square, and if you continue like this, so this difference between this number and this number, or this number and this number, you just calculate and see that the difference will not be constant, so it is not an arithmetic progression. In arithmetic progression, the difference has to be constant. Like here 150 plus 50 is 200 plus 50 is 250. The difference between this number and the preceding number has to be constant. Write the first four terms of AP when the first term A and the common difference D are given below. This is A and D is given below. So first four term you have to write. This is 10 is the first term, then difference is 10, then it will be 20, then 30, then 40, the difference is 10. Similarly here it is minus 2 and difference is 0, so it is minus 2 minus 2. Just go through it, it is very simple, and let me not waste time doing simple things. Now third, for the following APs, write the first term and the common difference. The first term here is 3, here A is 3, and the difference between this is minus 2. So 3 minus 2 is 1, then 1 minus 2 is minus 1, so difference is minus 2. Similarly here first term is A third and D is 4 by 3. Just go through it and see. 5 by 3 minus 1 by 3 is 4 by 3. And similarly here A is minus 5 and D is, this is minus 5 plus 4 is minus 1, so D is 4, then minus 1 plus 4 is 3. And similarly here first term is 0.6 and the difference is 1.1. 0.6 plus 1.1 is 1.7, and so on and so forth. Now fourth, which of the following are APs? If they form an AP, find the common difference D and write 3 more terms. So you add 3 more terms, so 2, then 4, this is difference 2. So this is not arithmetic progression. The difference is here 4, 8 minus 4 is 4, 16 minus 8 is 8. So difference is changing here 2, then 4, then it should be same, constant, as I mentioned. So this is not arithmetic progression. Second, 2 comma, this is comma here, 5 by 2 comma 3 comma 7 by 2. That means 2, 2.5, 5 divided by 2 is 2.5, then 3, then 3.5. So difference is 0.5. So this is arithmetic progression. So D is half, is 0.5, and after this term will be, after 3.5 will be 4, then 4.5, that is 9 by 2 is 4.5, then 5. So next 3 terms which they have told to write 3 more terms. So similarly go through all this. These are all very simple and the answers are given here, and this I have given the answer because many people may not have the textbook, so they can verify this from this. Another example, find the 10th term of the AP 2, 7, 12. What will be the 10th term? So here this formula, as I said, please remember this formula. Use n term is an is equal to a plus n minus 1d. So n should be 10. So what is it here? A is equal to 2 and d is equal to, it is 5. 7 minus 2 is 5. 12 minus 7 is again 5. So d is 5 and we need to find n equal to 10. So a10 is, a is 2 plus 10 minus 1 into 5, that is a10 is 47. Another example, which term of AP 21, 18, 15, it is reducing by 3. So 21 minus 3 is 18, 18 minus 3 is 15. So which term of AP is minus 81? Also, is any term 0? This is a question. Give reason for your answer. So again here you take a equal to 21, the first term. Difference is minus 3. So an is equal to minus 81. So what do? I use this formula, minus 81. This is minus 81 is equal to 21 plus, I have to find which term, n I have to find. So I have one unknown and one equation. So it is easy to find what the value of n is. So here if you simplify it, you will get n equal to 35. And then they ask, is there any n for which an is equal to 0? If such an n is there, then 21 is the first term plus n minus 1 minus 3 is equal to 0 implies n equal to 8. So for n equal to 8, you will have, that is 1, 2, 3, a1, a2, a3. If you continue, you will get a8 equal to 0. Another example, determine the AP, that is arithmetic progression, whose third term is 5 and the seventh term is 9. So again I use this formula. This formula is very important, as I said. Again I use the same thing. Third term is 5, that is a 3 minus 1. N is the third term, n is 3. So that is a plus 2d is 5 and a7 is 9, that is 7 minus 1. So a plus 6 is. So now you have two simultaneous equations. So if I subtract this, I can get a d from here. So kindly please do it. In our last lecture, we have shown how to solve two simultaneous linear equations to get this element a and you have two equations here. So you will get a equal to 3 and d equal to 1. Hence the required arithmetic progression is first element is 3, then you have to add 1, then you get 4, then again difference is 1, 5, 6. So this is the arithmetic progression which has been asked. Now exercise 5.2. Fill in the blanks in the following table given that a is the first term, d the common difference, and an is the nth term of the AP. So again I said, just remember this form. The whole chapter is based on this equation. So I know it is very simple, but anyway, for the sake of completeness, let us do it. So what is an? So you have a is 7, then d is 3, n is 8. So you just solve this and you will get an. So similarly, substitute these values and you will get this. So I will not go because it is too simple. So I think you all should able to do it. And anyway, the values I have put here, this is I have again cut pasted from the book, exercise 5.2 solution. So here an is 28, d is 2. So kindly do it and find out, because you have only one unknown and one equation. It is easy to find what is that unknown. Okay, unknown can be a, unknown can be n, unknown can be d, or even unknown can be n. Okay, so once you know this and one unknown, you should able to find it by rearranging the numbers. Okay, now second, choose the correct choice in the following and justify. 30th term of AP, that is 10, 7, 4. What will be the 30th term? For this one, the answer is this. How do you get a 30 is first term is 10, then you are asked what is the 30th term. So n is 30 minus 1 times difference is it is minus 3. 10 minus 3 is 7, 7 minus 3 is 4. The difference is, so you get minus 7. So this is the answer. C is the answer. So here second, C is the answer. Similarly for second one, 11th term of AP is minus 3 minus half then 2. What will be the 11th term? So again same here, a11 is equal to, I use this formula. First term is minus 3, 11 minus 1, because they have asked to find the 11th term. So n is 11 minus 1. So here it is minus half and minus 3. So minus 3 plus 2.5 you will get minus half. Minus half plus 2.5 you will get 2. So the difference is 2.5. So I substitute this 2.5 and I get this answer 22. So for this one, B is 22. This is the one. So let me go quickly because these are all based on this formula. So it's just a repetition. So anyway, for completeness sake, it is simple. In the following APs, find the missing term in the box. This is the first term and this is your second, this is your third term. You have to find the second term. So third term A3 is 26. First term is A is 2. Then 3 minus 1 is 2 and difference is D is. So we have to find what is this D. So you have one equation, one unknown. So you take 2 to this size 24. 24 divided by 2, D is 12. Second, now we have to find this first term and the third term and we don't know what is the difference. So we have to find, if we know the first term and the difference, then I can find the rest. So how do I do it? I have been given this. This is 13. This is A2. A2 is equal to A1, which I have to find A plus D. This also I do not know. So I write D. And then this is your first, second, third, fourth. So the A4 is 3. A plus this is n minus 1. A4 minus 1 is 3 times D. So now you have two equations and two unknown. So now I can find what is A and what is. Just go through this. You will find the first term is 18 here and the third term A3. This is subscript 3 is 8. So 18 and 8 for the second. So similarly you do for the rest. I will not do here. You have to do, it will become slightly lengthy, but it is doable. Which term of AP 3, 8, 13, 18 dot dot is 78. So 78 is which term? So 78 is first term is 3. I have to find n, which term it is. So which the nth value I have to know. Nth value is given as 78. So n minus 1 5. So I have to find this one equation and one unknown. So it is possible to find. So you just rearrange and you will get n equal to 16. Similarly, find the number of terms in each of the following APs. You have 7, 13, 19. So how many terms will be there? So first term is 7. This is the last term an. So n minus 1, this is the formula. And the difference is 7 plus 6 is 13. 13 plus 6 is 9. So difference is 6. So you put it here and you will get n equal to 34. So you have 34 number of terms. Similarly, you do for this also. Check whether minus 150 is a term of arithmetic progression. This is reducing. So definitely it will go to negative side. So is minus 150 is one of the terms. So how do I find out? This is minus 150 is the thing which is given to you, an. That is 11 is the first term. N minus 1 and the difference is minus 3 because it's reducing. That implies now you have one equation, one unknown. So again you can easily find. Just go through this and you will find that n is 164 by 3, which is not an integer. So this term does not exist. It has to be, n has to be an integer. Okay, now this looks a bit clumsy. So let us go line by line and maybe some of them we will skip. So here find the 31st term of an AP whose 11th term is 38. So this is the 11th term. 38 is equal to A plus 11 minus 1 is 10, 10D. And 16th term is 73. This is the 16th term means n minus 1 will be 15. This is 73. So now again you have simultaneous equation. You can solve it. So here you solve this by elimination method. This I have multiplied it by 3 and this 15 by 2. So this 30D, this is 30D. So I can eliminate. I can find what is A. And similarly, once I know what is A, I can find what is D also. And once I know what is A and what is D, so A is minus 32. And then they have asked to find the 31st term. So n minus 1 will be 30. And the difference is 7. So it is 178. So answer is for the 7 is 178. And these are the answer for those students, those who do not have the textbook and can see and cross check their answers. Now 8, an AP consists of 50 terms. So it consists of 50 term of which third term is 12 and the last term is 100. Find the 29th term. Okay. So what are given? You have given third term is 12. So 12 A 3 minus, that is the third term will be n minus 1, that is 3 minus 1 is 2D. And then also you have been given 50 terms. So the last term is 106. So 106 is for the 50th term. So that means 50 minus 1 49D, and this is the first term. So again now you have two simultaneous equation and you please kindly solve it by elimination method and you will get A is equal to 8 and D equal to 2. So they have asked to find the 29th term. So n minus 1 is 29 minus 1 is 28. So first term is 8 plus 28 into 2. 2 is the difference. So these are simple. So let me not, you should now do it. This formula only you have to use. This is only formula which the whole chapter is based on this formula. Those which are a bit tricky, I have tried to do it. So now 13, how many 3-digit numbers are divisible by 7? So 3-digit means numbers beyond 100 and less than 1000. So beyond 100 we know we can use calculator and find this 105 is the first element which is divisible by 7 beyond 100, and the last element is 994 before 1000. So this is the last element for 105 and 994. So I can write 994 is equal to first element 105 plus n minus 1 and 7 divisible by 7. So 7 is the difference. So I can get n equal to, so there are totally n equal to 128. So you will have 128 such numbers in the arithmetic progression. How many multiple of 4 lies between 10 and 250? We know that 4 goes into 12 and also the last number before 250 is 248. So this is the first A and this is your an. So an is 248 is equal to 12 plus n1. So n equal to 6. So very similar one. Find what value of n are the n term of two APs 63, 65, 67 and 3, 10, 17 are equal. So here they have asked at what value of n the two element from this AP and from this AP will be same. So I do not know what the n will be. So I write x equal to, this is the first element is 63 for this one, n minus 1 the difference is 2. So I have this equation 61 plus 2n, and for the second AP x equal to, this element should be same, 3 plus n minus 1 times 7, because 3 plus 7 is 10, the difference is 7. So I have one more equation. So now I have two unknown and two equations. So I can subtract this x, I can find n equal to 13. So for n equal to 13, these two are same. Now 16, determine the AP whose third term is 16 and the seventh term exceeds the fifth term by 12. So here the third term, that is a plus 2d, 3 minus 1 is 2, is 16, and seventh term exceeds the fifth term. So that means a is is constant. So 7 term minus 5 term, that is 7 term will be 6d minus the 5th term will be 4d, because this a will get cancelled. Only d, these differences will be remaining, and that is equal to 12. So now again you have two unknown a and d, and you can have two equations, so you can find a and d. Here 6d minus 4d is 2d, so d is equal to 6. So once d is equal to 6, you put 6 to the 12. So a has to be 4. So these are very simple. The answers are given here. Now from here onward, I will request student to go to my class 9 lecture 7 on areas and volumes. Here I have, this is taken from there, just cut and paste it. So this is a summation. Suppose this is power 0. So summation of the numbers, natural numbers 1 plus 2 plus 3 and so on up to n. And if each number is to the power 0, so any number to the power 0 is 1. So you have 1 plus 1 n times. And this summation can be denoted by this symbol, that is s to the power 0. That is 1 plus 1 equal to n. And if suppose instead of 0, I take 1 to the power 1 plus 2 to the power 1 plus 3 to the power 1 and so on. So I get s to the power 1 or s of 1. This is 1 plus 2 plus 3. So this sum I can also write as, I reverse it, n plus n minus 1 plus n minus 2 like this. And you add them, you have n plus 1. Then n minus 1 plus 2 is n plus 1. N minus 2 plus 3 is n plus 1. So you will have n of these things, n times of n plus 1. So I can write n times of n plus 1. And now this is, you have added this s plus s is 2s. So I take this 2 down. So this summation of this 1 plus 2 up to n is n into n plus 1 by 2. So suppose you have to add up to 50, then this is 50 into 51 by 2. So that will be the summation. So similarly, one can extend the sum of the first n terms of AP. That is the arithmetic progression. This is the arithmetic progression. So n term of AP, I have shown that it is equal to this one. And let S denotes the sum of the first n terms of the AP we have. So now you have to add, this is the sum, add all A plus AD up to n, AN, that is AN is A plus n minus 1 into D, which we have shown earlier. Similarly, like what we did earlier, you reverse this and again you add this plus this, then this plus this. So this plus this is 2a plus n minus 1d. Again you have here, this is a plus a, then d, this is n minus 2, d plus d, that is n minus 1d again. So you will have this again 2a plus n minus 1 times d n times. Just pause it, see what I am saying. And when you add this s and s, you have 2s. So similarly 2s is equal to n times, because there are n, this is n times, is a bracket here, this big bracket, n times. So n times 2a plus n minus 1d. So s is equal to this 2, you bring it down. S is equal to n by 2 times 2a plus n minus. Or you can write as n by 2, this a plus, this is 2a is a plus a is 2a. I write here a plus a, and this one is an. So I write the sum of this arithmetic progression as n divided by 2, the first term, and the nth term. And how many times the terms are? This is the number of terms, n. So here you can see that if a is 1 and your difference is 1, then you get s is equal to n into n plus 1 by 2, what we have derived earlier for 1, 2, 3, this element. Okay, this is also arithmetic progression. Difference is 1, 1, 2, 3, 4. So 4 minus 3 is 1. So difference is. So this is the summation what we derived earlier. Example 14, find the sum of the first 1000 positive integer. So s is equal to 1 plus 2 plus 3 up to plus 1000. So I use the formula Sn is equal to n by 2 a plus the last term, or an. Okay, so what is n? N is 1000. You have n number 1000 terms by 2, a is 1 and l is 1000. So you get, this is the sum. Just do it, pause and see. So the sum of the first 1000 positive integer is this number. And second, find the sum of the first n positive integer. So this is same as what we did in a previous slide. That is Sn is 1 plus 2 plus 3 plus n. So I can use this formula, a is 1. Okay, and an, the last term is n. So 1 plus n times n by 2. So n by 2 times n plus 1 is the same thing. Okay, now we summarize this chapter. In this chapter you have studied the following point. I will not repeat what I have written here. Just pause it and read it. So we have done all this. Arithmetic progression is written like this. And this is your difference. And this is the formula which we have used extensively in this lecture. The sum of first n term of arithmetic progression, we have proved this. And if L is the last term of the finite AP, say the n term, then the sum of all the terms of the AP is given by this. Also we have shown it how to do it. And if A, B, C are in arithmetic progression, then B is in between. Okay, it's a mean. Okay, it's called the arithmetic mean of A and C. A plus C by 2 will be B. Okay, so I think we have covered your chapter 5 of arithmetic progression. This is a simpler chapter. So next chapter on statistics we will do in the next lecture. And thank you and see you in next lecture.